I'm Algebra Annie, and I'm here to help you be successful in your algebra class. With new day comes new strength and new thoughts. Eleanor Roosevelt. Our learning targets today are: I can create and interpret scatter plots. I can use trend lines to make predictions.
So now we're looking at scatter plots and trend lines. And before we move into the lesson, we need to talk about a couple of definitions. So our first definition is a scatter plot. So a scatter plot is a graph with points plotted to show a possible relationship between two sets of data. It's a possible relationship because sometimes there isn't one. Scatter plots are discrete graphs. And if you remember from our previous lesson, that means that they are not connected. So scatter plots are literally a bunch of scattered points along a graph. So now we're being asked to graph our first scatter plot. So this table below, it shows the number of species added to the list of endangered and threatened species in the U.S. during given years. So in 1996, 91 species were added to the list. In 97, 79 were added to the list. In 98, 62 were added to the list. And it keeps going up to show us how many were added all the way up to 2002. And then I have a plain piece of graph paper back here. I apologize, I had to kind of draw in where a space, for some reason my printer did not print. So somehow we need to put this table into this graph. So the first thing is we need to know what we're talking about. So we had a story, so this entire graph needs some kind of title. So this is the number of species added to the list. So we're going to title this the number of species added to the list. Now what exactly are we graphing? We are graphing the calendar year. Well, time is usually the x, and the first thing always listed is the x, so that's the x-axis. So down here is our calendar year. So I have calendar year. And then the y is always the last one mentioned, species. So this y-axis is our species. And it's the number of species. So we're going to do number of species. So we have our years that we need to mark down here. So I'm going to skip a couple spaces each time, and you can really scale it however you want. So I just wanted to scale it by skipping 2 blocks each time. So this block right here is going to be 1996. This marker is 1997, 1998, 1999, 2000, 2001, and 2002. There is another space, but we ran out of room. You could write the next one, which would have been 2003. You're just not putting anything there. And then I need to count my species. Well, I see the highest number was 91. So if I counted by fives, let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Counting by fives wouldn't fit. So I need to count by tens. So I start at 0. There's 10, 20, 30, and I go all the way up counting by tens on each marker until I've counted high enough to get to my largest number, and I did. So in 1996 there was 91. So 1996 I need to put a dot on 91. 97 it has 79, so 97 there's a dot on 79. 98 was 62, so here's 98 dot on 62. 99 was 11 dot on 11. 2000 was dot on 39, 2001, 10, and 2002 it's a 9. So since it is a scatter plot and they told us to make a scatter plot, if it's a scatter plot you're not connecting. So this is our table and we're done. So what is the first thing that we did? The first thing we did was we labeled the graph and the axes. After we labeled all of our parts, the next thing that we did is that we scaled our axes. Now, one thing about the axes, you need to be very careful when you're scaling. The numbers need to be the same each time. On my y, or on my x, I was always counting by 1. On my y, I was consistently always counting by 10. You need to be consistent with your scales. Always count by the same number. Don't jump around. Next thing we did, we plotted our points. Then you do not connect because it's a scatter plot. Scatter plots are not meant to be connected. Our next example, we're asked again to make a scatter plot, but this time the table shows the number of points scored by a high school football team in their first 4 games of the season. So here's our graph that we need to make a scatter plot with. So the first things first, we need a label. So I'm going to label this our football scores. So football team scores. And what were we looking at? The first thing labeled, which is always your x-axis, the first thing is which game we were looking at. So let's go ahead and title our x-axis whatever game we were looking at. And I need to scale it. So I see us counting by ones. I've got plenty of room that I could count by one. So no games, the first game, the second game, game 3, game 4, game 5, game 6, game 7. I continue to count out even though we only have info for 4 games. I just finished the scale. Now the second thing labeled is always our y-axis. So our y-axis must be the score that they earned that game. I see the highest it went to is 46. So this time I know I can count by 5s and that it will fit. So I'm going to go ahead and I'm going to count by 5 so that it fits. Now you'll see that I'm actually writing by 10s, but it's because it's 5, 10, 15, 20, 25, 30. So I'm still counting by 5s. It's just that I skipped squares. So it looks like I'm counting by 10s, but I'm counting by 5s. So on game 1, they earned 6 points. So in game 1, we earned 6 points. Game 2, they earned 21 points. So game 2 was 21 points. Game 3 was 46 points. Game 3 is a 46. And game 4 is 34 points. So game 4 is 34. There you go. That's not a point. So game 4 was 34 points. There we go. And it's a scatter plot. So we are not connecting. These are just the 4 points right there. So now we have another definition we need to look at. We have a correlation, and that describes a relationship between 2 data sets. So a graph may show a correlation between data. The correlation can help you analyze trends and predictions. The key word is that it helps. So there's 3 different types of correlation that you could have. So to figure out which each set is, or to figure out what kind of correlation your data set has, what you should do is that you should make a tight bubble around your data. So go ahead and make a tight bubble around your data. So this first one here is the tightest bubble I can make. So there's a tight bubble. The second one here is my tight bubble. And the last one can't really make. There we go. There's a tight bubble. So now looking at your tight bubble, this one tends, because we read graphs from left to right, I can see that this one tends to go this way. Reading this tight bubble, because we read from left to right, it tends to go this direction. This tight bubble, I don't see any direction on it at all. I'm actually kind of confused by him. He looks like a blob, like an amoeba. So if you remember Slope Dude, what did Slope Dude say when he was going this direction? Slope Dude was saying puff puff positive. What was Slope Dude saying when he was going down in this direction? He was saying nice negative. And since we're confused by that one, we'll go to that one later. So puff puff positive. You could pretty much probably guess then that this is going to be a positive correlation. And the official definition of a positive correlation is that both sets of data, so both sets of data values increase. So as this one went up, this one went up, 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 up. So both sets of data increased. Well, since this one was nice negative, you can probably guess that this was a negative correlation. And the official definition is that one set of data value increases as the other set decreases. So I had to go down to move over, down to move over, down to move over. So one increased while the other decreased. Well, if this is both of them increasing, this one is one increase, one decrease. The only other option is that there's actually no correlation at all. If you're absolutely totally confused, that meant that there was no correlation. And the official definition for no correlation is that there is no relationship between the data. So now we have some 3-story problems where we need to see what kind of correlation would those story problems have. So number 1, the number of empty seats in the classroom, so how many empty desks I have, how is that related to the number of students seated in the class? So if I'm thinking about this, so going through the story problem, as more students enter class, so when more students come in, what happens to my empty seats? The number of empty seats, I run out. They're going down. So the number of empty seats decreases. So as more students come into class, so as one value goes up, the number of seats decreases. So as one goes up, the other one goes down. If you remember that sheet we looked at, which one, where when one goes up, the other goes down? It was a negative correlation. So our answer to this is negative correlation. Well, now let's look at the other one. The number of pets a person owns. How is that related to the number of books that the person read last year? So I'm thinking about this, and I'm actually really confused because how many books or how many pets I own has nothing to do with how many books I read. They have nothing to do with one another. There is no relationship, so there is no correlation because they have nothing to do with one another. Okay, last one. The monthly rainfall. What does that have to do with the depth of the water in the reservoir? So a reservoir is like a pool that holds all the water for us. So if we have a lot of rainfall, we have a lot of water. If we have no rainfall, we have no water. So if we have a lot of rain, so the more rain we have, what happens to the water? Well, if we have more rain, that meant more water is actually going into it, which meant the depth is getting higher. So that meant the more water in the reservoir. So if we have more rain, then we have more water. More and more, if you look at the cheat sheet we did before, both sets of data are increasing. So this is going to be a positive correlation. So this is a positive correlation. So now we have a problem where you are being asked to choose which scatter plot best represents the number of days since a sunflower seed was planted and comparing that to its height. So if I wanted to first look at each one individually and look at the story that graph is telling. So looking at this and ignoring these guys. So on day 0, my plant was instantly 70 inches high. And then on day 10, it shrunk. Day 20, it was still the same. Day 30, it was taller. On day 40, it shrunk again. So my plant instantly started very tall, and then it shrunk, stayed, got taller, shrunk, got taller, shrunk. So my plant, so the height of the flower, it keeps going up and down. Doesn't make sense for a height of a flower to first start at 60 as a seed and then go up, down, and down. That doesn't make any sense. So the fact that it started off at 70 inches tall as a planted seed doesn't make any sense. And then it bounces around in its height, which also doesn't make any sense. So this story doesn't make sense. Since it doesn't make sense, this is probably not the graph to represent our story. So now looking at this one. Our first height isn't on day 0. Somehow our first height's all the way over here at like day -30. It doesn't make sense to have negative time, and it doesn't make sense to have negative height when you're measuring the height of a seed. So what did this story tell us about? It said the height of the flower or our seed started as a negative, and that doesn't make any sense. Time was also negative, which makes no sense. So this story doesn't make sense. Since it doesn't make sense, this is probably not the scatter plot to represent our story. Well, if the first two didn't work, process of elimination, the third one probably works. Let's look at why. So on day 0, the first day our seed was in the ground, he was 0 tall. Well, that makes sense. And then I could see as time goes on, my seed is slowly getting taller and taller and taller. And that's what seeds do. So the height started at 0, which is what it should be, and it slowly increased over time. That makes a lot of sense. So yes, I believe that this is the proper scatter plot to explain the height of a seed over time as the plant grows. So this is the last thing we need to talk about today. So scatter plots are not connected, but if you were to design a trend line is a line that you can put on a scatter plot, and it will help you show the relationship more clearly. So it helps us make predictions based on the current path and the current movement. So we're supposed to look at this scatter plot that shows the number of wrapping paper sold to the money you raise at a school fundraiser. And we're supposed to answer these two questions. The best way to answer these questions is to design our own trend line. So a trend line is you making a line that's in as close to the middle of all of the data as you possibly can. You can see through my ruler. I'm in as close to the data as I possibly can. So your trend line may end up looking different than mine, slightly different, but it's going to be the same general direction. We're in as close to the middle as possible. So now looking at this as close to middle trend line as possible, so look at this trend line. Can we predict how much money will be collected when I sold 175 rolls? If the trend line was not there, I would have had no idea because there's no dot there. But now that I have a trend line, 175 rolls is right here. Go up. I ran into my trend line right there. So I can make a prediction that I would have sold and made $1,200. So based on my trend line, I can predict that $1,200 will be collected when 175 rolls are sold. Now it is a prediction, so that might not come true, but it's a guess. It helps me kind of plan ahead for the future. So the next question, based on that trend line that I drew, how many wrapping paper rolls will need to be sold to raise $500? So if I wanted to make sure I sold $500 right here, that ran into my trend line right here, which related to whatever number this is. Well, it's halfway between 50 and 100. It's probably 75. So based on my trend line, I will need to sell 75 rolls to raise $500. So how do you make a trend line? We drew a trend line by drawing a line as close to the middle of all the data. This is your trend line. So it's as close to the data as possible.
What did we learn today? I can create and interpret scatter plots. I can use trend lines to make predictions, and I look forward to seeing you tomorrow in class.